Hey everyone, in this video we're going to go over some key features of functions, specifically the domain, the range, and the end behavior of graphs. It will be really helpful to you if you can remember at least the domain of those parent functions. If you remember a lot of the parent functions, the domain is all real numbers because there's an arrow to the left and an arrow to the right. So being able to identify what kind of a function you're looking at can be really helpful. These particular graphs, you might recognize some of them, but their domains are just a different example. So first of all, domain is from left to right. And one thing you want to notice when you're finding the domain and range is if your graph is continuous. Continuous means it's connected. You can start at the left and without picking up your pencil, trace the entire graph. So that lets you know that the domain and range are going to be pretty self-explanatory, like just a low to a high. You're not going to have any crazy things in between. All right, another thing to remember is a parenthesis is when things are left open, and we use a bracket for when things are closed. So open could be an actual open circle point on the graph. It could also be an asymptote where the graph is approaching that asymptote, but it's never going to actually intersect that asymptote. We also always use a parenthesis for infinity and negative infinity because those are not actual numbers that we could plot. But anything that's an actual point on the graph gets a closed circle and a bracket. All right, so I'm going to do the domain of all of these first. So the domain is how far to the left and how far to the right the graph goes. If you approach the graph from like off the paper and you go to where the graph starts, I can see that the first x value of this graph is -3. And I don't know if you can see, but there was an open circle there. So my domain is going to be -3. And again, it's continuous, so I don't have to worry about any weird breaks, but come from off the paper and then approach the graph from the right. And I can see this x value is 1. And that's a closed circle there. So 1 will get a bracket. All right, example number 2, come in from off the paper. And again, when you give domain and range, you're not telling me how far they labeled the scale. You have to make sure that you're actually on the graph. So if I notice the very first thing that my pen is hitting from the left is an arrow, that arrow is going to continue to point to the left. So any arrow that is going to the left is negative infinity because the left is negative on this graph. So this graph will continue to the left forever and ever and ever, even though like it's easy to see that this is pointing down. But if I were to try to plot the next point, I would have to go left, down, left, down, left, down. So I am going to the left. If I come in from the right, I can see that the first x value that I hit is 5. There is a closed circle there. So 5 gets a bracket. Example number 3, coming in from the left, I can see that leftmost point of my graph is at -2. There is a closed circle there, so that gets a bracket. On the right, I have an arrow. And so that's going to point to the right forever and ever and ever, which is positive infinity. All right, range, we're going to follow the same strategy, except we're going to start from the bottom and go to the top. So bottom to top, if there was a minimum to the maximum. And the same rules apply for the parentheses and the bracket. All right, so I'm going to approach my graph from the bottom. And that's all kind of matching up, so it doesn't really matter which one you want to look at it. But I can see that the lowest y value on this graph is at -4. There is an actual point there. Those are points, so they get a bracket. And if I approach the graph from the top, Again, those all kind of line up, and so I can see that the highest y value will be 0. Now, there is a closed circle here where this point is hitting. So the fact that this point is included, that's an actual point, this is going to get a closed bracket. Even though there's an open circle over there, that point does exist on this part of the graph. All right, example 2, coming in from the bottom, I had an arrow that means negative infinity because it's pointing down. If I come in from the top, I can see that the highest y value is 2. Example number 3, coming in from the bottom, y value, that looks like negative 1. That's the lowest point on the graph. There's an actual point there, so it gets a bracket. And the top of my graph, I hit an arrow, so that arrow is going to continue up. So positive infinity. All right, moving on to end behavior. End behavior can be super challenging if you don't understand how to read it. So there are 2 very important parts of the sentence for every single end behavior problem. And you need to be able to identify those 2 pieces. Otherwise, you don't really know what the graph is asking you for. So one of them will say, as x approaches positive infinity. Positive infinity on the x-axis is to the right. So that is just a fancy way of asking you what the right arrow is doing. The other piece is as x approaches negative infinity. Negative on the x-axis is to the left. So the very first thing that you want to do with the end behavior problem is either write those 2 things down if it's a totally open problem. A lot of the time those are a part of the answer choices, or those are already there and you have to fill in the blank. But you need both of those. You can always put does not exist or NA, but every graph starts off with we describe what's happening to the right arrow and we describe what's happening to the left arrow. So as x approaches infinity, so that's the arrow on the right, your job is to describe what the right arrow is doing. Well, the right arrow is pointing up. So you can either say y is going up, or you can use f of x. Those are the same thing. And sometimes, depending on how much time I have, I just swap back and forth between writing it with y and writing it with f of x. But the fact that that arrow is pointing up forever and ever and ever, so that would be positive infinity. That arrow is pointing up. All right, now I need my statement for the left arrow. So that starts with as x approaches negative infinity. That's the arrow on the left. And for this graph, that arrow is also pointing up. So same thing, we can use y or we can use f of x, but the fact that it's going up means we will put infinity. Forever and ever and ever up is infinity. All right, I'm gonna switch colors for the next example just because I don't want those 2 examples to get confused. All right, so same thing, we need a right arrow statement and we need a left arrow statement. We have 2 arrows. We need a left arrow statement and a right arrow statement. So in this case, my right arrow is pointing down and my left arrow is pointing up. So because I'm running out of space, I'm going to use y. My right arrow is down. Down would be negative infinity. My left arrow is up. up would be positive infinity. All right, I'm going to switch back colors again just because these are kind of bleeding into each other. All right, so for example number 3, again, I always need my right arrow statement, my left arrow statement. I need an x positive infinity and an x negative infinity all the time. One for the right, one for the left. All right, so for this one, the left is going to be a little bit easier, so I'm going to do that one first. The left arrow is pointing up. That's pretty easy. So my left arrow is pointing up, so up gets positive infinity. Down gets negative, up gets positive. But this is exponential, so the end behavior when you have an asymptote is a little bit different because that arrow is going to continue to the right, but it's not really pointing up or down. It's leveling out. It's getting really flat. And so the number that it's approaching is wherever this horizontal asymptote is. So in this case, I can tell that that horizontal asymptote is 0. So this one is actually going to be approaching a number. So whenever you have a horizontal asymptote, that whatever arrow is like flattening up against the horizontal asymptote, that number is what you're going to be putting for the end behavior. The y is approaching 0 because I have a horizontal asymptote when y equals 0. All right, the next video is going to go over increasing, decreasing, positive, and negative.